Quorum consistency, a cloud-native PG operator imperative ensuring data integrity during Postgres cluster transformations. The upcoming POSET conference event focusing on Postgres 2026 centers on a critical challenge within the evolving landscape of distributed database management. The application of Quorum consistency to Postgres cluster changes facilitated by the cloud-native PG operator. This presentation, co-led by Jeremy Schneider of Geico and Leonardo Secchi of EDB, directly addresses the inherent complexities surrounding maintaining data integrity as Postgres clusters migrate and evolve within Kubernetes environments.
The urgency stems from the increasing reliance on containerized database solutions and the demand for robust, high-availability systems capable of adapting to dynamic operational requirements. This exploration is paramount to mitigating potential data corruption and ensuring operational resilience for organizations leveraging PostgreSQL and cloud-native deployments.
The rise of distributed Postgres in Kubernetes. Understanding the critical need for operational stability. Historically, Postgres cluster changes, such as scaling or failover operations, have relied on traditional replication models, often introducing vulnerabilities and potential inconsistencies, particularly within geographically distributed environments. The integration of the cloud-native PG operator introduces a new paradigm, automated cluster management, but necessitates a sophisticated approach to maintaining data integrity during these transformations.
The current market demands a heightened level of operational stability, driven by the proliferation of Kubernetes deployments and the increased complexity of managing distributed database systems. The core issue is the potential for data divergence during asynchronous operations, requiring a proactive approach to maintain quorum consistency and prevent data loss or corruption, a risk significantly amplified by the inherent challenges of distributed systems.
This shift demands a meticulous understanding of the underlying mechanics of Postgres replication and the operator's role in orchestrating these changes.
Leveraging Quorum for cloud-native PG operator resilience. A deep dive into data synchronization mechanics. The cloud-native PG operator's architecture relies heavily on the concept of Quorum consistency to guarantee data integrity during Postgres cluster modifications. Specifically, the operator utilizes a multi-master replication topology where a majority of nodes must acknowledge a change before it is considered committed, effectively establishing a quorum.
This mechanism mitigates the risk of split-brain scenarios, a critical concern in distributed systems, where conflicting updates could lead to irreversible data corruption. The operator leverages Slonic, a high-performance PostgreSQL driver, to facilitate efficient data synchronization across the cluster.
Furthermore, the operator's monitoring and alerting capabilities provide real-time visibility into the replication lag and potential inconsistencies, allowing for proactive intervention. The operator's configuration allows for granular control over the replication factor, directly impacting the resilience and consistency guarantees offered to the Postgres cluster.
Successfully implementing this approach is vital for organizations seeking to maximize the benefits of cloud-native database deployments while minimizing operational risk.
Strategic implications and future risk mitigation. Navigating the evolving Postgres landscape. The adoption of quorum-based consistency within the cloud-native PG operator represents a strategic imperative for organizations transitioning to cloud-native Postgres deployments. However, continued vigilance is crucial. Potential risks include misconfiguration of replication parameters, network latency impacting quorum establishment, and unforeseen interactions between the operator and other Kubernetes components.
Future opportunities lie in further automation of conflict resolution and enhanced monitoring capabilities, potentially incorporating AI-driven anomaly detection to proactively address inconsistencies. Organizations must prioritize thorough testing and validation of their Postgres cluster configurations, particularly during periods of significant change, to ensure ongoing data integrity and operational resilience.
Moreover, ongoing engagement with the PostgreSQL community and proactive participation in the development of the cloud-native PG operator are essential for mitigating future risks and maximizing the value of this transformative technology.